Hello everyone and welcome to our second video where we are going to prove the second theorem, which I regard as one of the most important and of course one of the most important theorem of the 7 theorems, right? So the statement says the angle subtended at the center of a circle is twice the angle subtended at the circumference by the same arc. So let's interpret that statement in relation to the diagram. So in the diagram, we are given that O is the center of the circle. Of course, we need to have that point, that O, as the center of the circle because the statement of the theorem itself involves the center of the circle. A, B, and C lie on the circle or on the circumference of the circle, and angles AOB and ACB stand on the same arc AB. So that arc AB is the one that subtend the two angles, or rather two reference angles. So this is the theorem that says angle at center equals to twice the angle at the circumference of the circle. So our MSH note says construction notes, we need to join O to C. So we need to draw OC. So we are going to do just that and produce maybe something there, maybe D. That's okay. And then that construction actually cut angle O. So this side we're going to have O1 and O2, and then we're going to have C1 there and C2. Now that construction as well produces two triangles, right? OCA and OCB. So those two triangles are produced as a result of that construction line. Now, what is it that we are required to prove? And how are we going to prove this? So we are required to prove that A angle OB equals to twice A angle CB. So that angle is twice that angle. So we are going to use triangles properties. Yes, once again, we are going to use properties of triangles. So this time around, we are going to use the exterior angle of a triangle equals to sum of interior opposite angles. So exterior angle of triangle, that angle right there outside that triangle, equals to the sum of those two triangles. So rather those two angles. So the sum of these two angles equals to this angle, right? So that is one of the most important properties of triangles. So now in our proof, it's fine. We are referencing the first triangles on the right? To say in triangle OCA, in that triangle, angle O1, right? Angle O1 is that one, equals to angle C1 plus angle A. Then the reason is exterior angle of a triangle, right? And then when you look at OC and OA, they are radius, right? So they are equal. OC equals to OA, and the reason is radii, right? And then since OC equals to OA, so it means OCA is an isosceles triangle because these two sides are equal. And we know the properties of an isosceles triangle is that the base angles are equal. So therefore, angle C1 equals to angle A. That's very convenient. The reason angles opposite equal sides. You know that from grade 10, grade 9. Therefore, if these two angles are equal, therefore angle O1 is simply equals to angle C1. So we are choosing angle C1 because it's the angle of interest. We don't care about angle A. It has done its job, and then we are done with it. So the reason why we are saying angle O1 is twice angle C1 is because angle C1 equals to angle A. So in this statement, if you replace A with C1, then we're going to have angle C1 plus angle C1, which equals to twice angle C1. Hence, angle O1 equals to twice C1. Right. Good. Now we're going to the second triangle, the one on the right. Right. So we're going to say in triangle OCB this time around, so angle O2, which is that angle, equals to angle C2 plus angle B. Right. So that angle equals to that one plus that one. And the reason is exterior angle of triangle. Right. So the angle outside the triangle equals to the sum of the two interior opposite angles. Right. And then OC equals to OB. Right. So OC equals to OB, which is equal radi. Right. Both radius. And then, therefore, if these two are equal, then we have another isosceles triangle, OCB. Therefore, if this two line equals to that line, therefore the base angles are equal, or the opposite angles are equal. Therefore, we have angle C2 equals to angle B. And our reason is angles opposite equal sides. Right, equal sides. Therefore, angle O2 equals to what? Guess what? Twice angle C2. Because we're going to replace C2 here. Rather, we're going to replace angle B with C2. So C2 plus C2 equals to angle 2 twice angle C2. Same as what we did in that triangle. So now we have angle O1 equals to twice angle C1. And then we have angle O2 twice angle C2. Then from that we can see something that we can use. So we can say that whole angle there, that whole angle, which is angle O1 plus angle O2, it means that is equals to twice angle C1 plus twice angle C2. But then what is angle O1 plus angle O2? Is that A angle OB, right? Is that one? Is that one we are required to prove? Okay, one side solved. So it means we can now reference back to say A angle OB equals to, but then we have a common factor here, which is what? Which is 2. Then we are going to take out our common factor, and then we're left with what? Angle C1 plus angle C2. Okay, now what is angle C1 plus angle C2? Angle C1 plus angle C2 is that angle right over there, A angle CB. Right. Therefore, A angle OB equals to twice what? A angle CB. That is our proof. We have proven that A angle OB equals to twice A angle CB. And how do we apply this theorem when proving? Is that angle at center equals to 2 times angle at circumference.